Hey everybody, Mr. Palacios here. I'm going to be going through really quickly 7.7.3, get you guys going so that you can finish additional practice and problem solving. As we do this, just make sure that you go back to the examples if you need them. And then if you don't, if you're ready for it, just go on to the next part. Okay, so we'll be looking at this. Unfortunately, I can't answer any questions because this is a video, but go back and review the parts until you get it if you need to. A vegetable garden has 100 tomato plants arranged in a 10 by 10 array. All right, so that means that there's 10 going down, 10 going across. 10 by 10, that's going to give us 100 plants, right? The gardener wants to know the average number of tomatoes on each plant. Each cell in the table represents a plant. So if you look down here, these are all of the plants in the tomato garden, and this is how many tomatoes are on each of the plants. So it varies, obviously, because it's tomatoes, right? The number in the cells tell how many tomatoes are on that particular plant. So let's look at all these plants. Wow, that's a lot of tomatoes. Because counting the numbers of tomatoes on all the plants is too time consuming, right? I don't want to say, okay, add all of these numbers together. That's going to be a lot. So what we can do is, well, what the gardener decides to do is choose 10 plants at random. So it could be this, it could be this, it could just be any of these at random to find the average number of tomatoes on them. Now, if we want to do this, it says to drop this on the floor and then just pick random ones at bat. What I'm going to do is, and you're going to watch me, I'm going to just choose at random and then I'm going to write the numbers off to the side or right here just so that we have that record, okay? So I'm going to start with, boom, this one, 60. This one, 64. 57. 71. 67. 63. 15. That's 1, 2, 3, 4, 5, 6, 7. I have 18, 48, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do one more. There. Oh, I already have 57. Boom. 74. Okay, so that's my 10 numbers. I'm just going to write them right here. 18, 15, 57, 64, 63, 71, 67, 74, 60, and 48. Okay, so those are my tomatoes. What is the average number of tomatoes on the 10 plants that were randomly selected? So what I need to do is I need to add up all the numbers, and then I'm going to use that number to find the mean. So the average number of tomatoes is going to be, hold on, I'm trying to turn on my calculator. Okay, so I'm going to do 18 plus 15 plus 57 plus 64 plus 63 plus 71 plus 67 plus 74 plus 60 plus 48. Okay, that gives me a grand total of 537. I'm going to divide that number by 10. I chose 10 numbers at random. And I'm going to get 53.7. That's my average, okay? So, let me erase these little circles since we don't need them anymore, these tomatoes. I just randomly chose red, people. Okay, so what is the average number of tomatoes on the 10 plants that were randomly chosen? 53.7. Alternatively, the gardener decides to choose the 10 plants in the first row. What is the average number of tomatoes on the 10 plants? So, first row, okay, I'm going to go this way, okay, rows, columns, rows, columns. So let's add these first rows really quickly, okay, 12 plus 18 plus 18 plus 14 plus 20 plus 11 plus 15 plus 9 plus 12 plus 10, okay, 139. Okay, 139 was the total number that I had. there were 10 plants. That's going to equal 13.9. So I have two different averages right here. They are very different from each other. How do the averages you got with each sampling method compare? Okay, my random sampling, the random sampling is much higher. Okay, so my random sampling was much higher than my just choosing the first row. And that is because that first row has a lot less tomatoes than the random ones that I chose. As you can see, my random ones are all in the, well, not except for the 18 and the 15, they're mostly in the 40s or above. Okay, 1A, how do the averages you got with each sampling method compare? We already answered that one. Okay, 1B, how do the averages you got with each sampling method compare to the average for the entire population, which is 56.3? So they added all 100 and then they divided that by 100 and they got 56.3. So you could say the first row is far below average. The random sampling is close to the overall average. Okay, then that's because the first row was 13.9 and the random sampling one was 53.7. That's very close to 56.3. I mean, it's not right next to it, but it's close enough. It's a lot closer than my 13.9 or 13.7. Why do you think the first method gave a closer average than the second method? I gotta change markers now. The first row has lower numbers of tomatoes overall. The random sampling includes plants with higher numbers of tomatoes. Okay, and they knew that the first method is going to give us a closer average because we're going to include higher number tomatoes. Whereas in that first row, when we look at that first row, it was a very straightforward, boom, these are how many tomatoes there are, and they were all low-bearing tomatoes, okay? When the information is being gathered about a group, the entire group of objects, individuals, or events is called the population. So population can mean people, it can mean plants, it can mean anything that we're taking data about, all right? A sample is a part of the population chosen to represent the entire group. So when you hear about population sampling, that means we're taking a small part of the group. If we looked at the entire school, a sample of students would be 7th grade. Okay, the entire population would include all of the students at our school. A sample in which every person, object, or event has an equal chance at being selected is called a random sample. A random sample is more likely to be representative of the entire population than other sampling methods. So if we just took 7th grade, you guys are not going to represent the entire population the way that just grabbing random students would. Hold on, Miss Lorna's here. Darn it.